All right, we're going to start this semester with Chapter 6, and Miss Grable is going to be going to the doctor today to see if she actually needs to have surgery on her injury. So we kind of are in limbo. We don't know exactly how long she will be out. But I'm going to do a recording for you today, and Miss Fanning will be able to kind of guide you and help you through the assignments that you will be turning in. She will be checking that by the end of the class period. Additionally, I'm going to teach you some calculator techniques, how to do some things on the calculator with this assignment. In addition to that, you're also going to need to know how to do some of this without a calculator, and I'm going to show you that when we get to it, because I know that tomorrow your assignment definitely you do without a calculator. Now I have a new substitute coming in for you tomorrow, and she is a past math teacher, so she does have that experience. So we've got somebody with the math background, so for the rest of the time that Miss Grable is going to be gone for you. All right, so let's get started here. So what we want to do is talk about the nth roots, and when you have a root, when you need to break a number down further than just taking the square root. Okay, you guys have done that a lot. You have done the square root. So whenever we were seeing the square root of a, it actually is meaning a to the 1/2 power. So then you could go into your calculator and type a to the 1/2 power and come up with your answer. Okay, but then what's happened is we now are going to start seeing things that have different signs in the index. So we're going to see cubic roots and quartic roots. So we're going to start seeing roots that are larger than just square root. Okay? So we will have our base underneath the radical sign. It's the radicand. And then, of course, we have our index. All right, so let's actually start doing some of these things together here. All right. And I need to be able to move this, so let's see. Okay. All right, so here with this example, example number 1, of course I have the answers written here, but what I want to do is teach you some things about it, not just the answers. Okay, I'm going to show you where to do this in the calculator also. All right. So with this first problem, problem A, what's happening is we want to be able to see what that does. Okay. Sorry, we'll go back to the other way. So what we have here is the cubic root of -8. So that is meaning, something times itself 3 times. Okay? So something times itself 3 times is going to be equaling -8. Okay? So you would know from your rules about signs that we are going to have 3 negatives in order to give us a negative value inside there. Okay? Now also, this is a small enough number that you may then be able to tell that -2 times -2 times -2 is how you get -8. Because 2 times 2 is 4, and then that times -2 makes -8. Now, in the calculator, here's how you do that. There is a way in the calculator to actually do the cubic root under the math menu. But I want you to get used to more than just cubic root because it doesn't have all the other roots in the calculator. So we're going to use this feature here. You need to put the entire -8. So you need to make sure that in parentheses you have the whole -8. And we want to go to the 1/3 power because that nth root is to the, and I'm going to put in parentheses, 1/3 power. So that's what that looks like in your calculator, -8 to the 1/3 power. And then you hit enter and it gives you your value of -2. Okay? Now, if you look at B, you have this value as a square root. Well, here's the deal. What's inside here is now positive and it is just a square root. So that's telling me I need two things to multiply together to give me 0.04. Well, I know that that's naturally not something that you're thinking of in terms of numbers, but they're decimals and such, so they're kind of bigger or smaller, different awkward numbers. So let's look at the square root, which is under second x squared. And then we're going to put in the 0.04. And so what the calculator gives us is the positive root, the 0.2. So yes, we know that 0.2 times 0.2 will equal the 0.04. But here is the thing. If your root is even, then you have to have a positive value in here, because you are having two things that multiply together to give you a positive value under the radical, okay? Negative times negative, or positive times positive. Therefore, when you have an even value, even radical, so second root, this one has a fourth root, E has a fourth root. When you have those ones, and D has a square root, so when you have an even root, you have to have two possible solutions, the positive version and the negative version, because negative 0.2 times negative 0.2 also equals the positive 0.04. So that's the one case that you have to watch out for. When you have an even root, you will have actually two answers. Okay, so let's take a look here at C. Okay, C is interesting in that it says we want to take the fourth root of a negative 1. So what that's saying is something times itself 4 times is going to come out to negative 1. Okay, well, anytime you multiply 4 items together, whether they were 4 positives, then you would get a positive number, not a negative number. Also, if you multiplied 4 negatives together, then you would be getting a positive, not a negative. So that is why this is called not real. It actually has an imaginary feature, and that is a different lesson. That one's going to be happening in the future, not yet. All right, let's take a look here at D. D has got a square root, and it's got the negative 2 inside. So notice what you are doing is taking care of what's inside first. So you're basically squaring a negative 2. Now, you better watch out on your calculator stuff whenever you are doing it, because watch this. This is a very common calculator mistake that happens. Here it is. Watch this. Negative 2 squared. The calculator gives me negative 4 as the answer. But what you intended it to do is negative 2 squared, and that's a positive answer. Do you see that? That is a small calculator difference, which makes a totally different answer. And here is why. Let me see if I can draw on this way. No. Here's why. Here's what's happening. If you type into your calculator negative 2 squared, guess what? The calculator is just squaring the 2, and then it tacks on the negative in front. All right, as opposed to this, in parentheses, negative 2 squared. Okay, guess what? Now this negative, or this 2 is squaring the negative and the 2. So it's negative times negative and 2 times 2. That's how you get the positive 4. So it's really important that you pay attention to including whether the negative is included in getting squared. And in D, the negative is getting squared. So what you have is the square root of 4. So since that is the square root of a number, it is positive and negative 2. Alright, let's look at number 4. I'm having issues with scrolling this thing. It's kind of being weird. So I can't scroll this up. So sorry, you're just going to have to look down at the bottom of the screen. Okay, E is saying we've got a fourth root. Okay, so if I have a fourth root, then I know that I need to have the inside be positive. Okay, otherwise it will be not real, like part C. Okay, and then the other thing is, let's talk about these big, huge numbers that we're just going to do in our calculator. And that's going to be the, I'm going to put in parentheses the entire value of 1296 divided by 625. Close that. Now, I want to raise that to the fourth root, to the, and in parentheses, 1 divided by 4. How could you put to the 0.25? Yes, you could raise it to the decimal, whatever. So see, it gives me this in a decimal, and of course we want to leave these in fractions. So we're going to do math fraction, which I'm sure Ms. Grable has shown you, and we've got the positive and the negative version of the 6/5. So you just need to remember your positive and negatives when you have an even root, square root, sixth root. So look here, I have an odd root. So now I don't have to worry about plus and minus. I only have to worry about the plus and minus whenever my root is even. Okay? Here, I only have to worry about the plus and minus when my root is even. Here I have an odd root, so I don't have to worry about the sign or having more than one root. I just have one root. So this one is 729 to the 1/3 root, and there's how I get 9. Okay, so there's all of that one. Let's go to the next page. Okay, so we got the next page here. I'm going to clear out our ink. I'm having technical difficulties because I could not get this page to show up in my smart notebook, so you just have to kind of bear with me on technical difficulties for right now. Okay, so here we go. Example 3 is where we start having to deal with, you know what? We totally missed example 2. Let me let you guys try that. Try example 2. I left that off. Okay? Try example 2. See if you can do those in your calculator. Then we'll check those real quick. There we go. Yay, I finally figured it out. Okay, let's try that. All right. Okay. So there we go. Square root. See, looky here. This is an odd root, so we just have one answer. It's the negative of that. Now, this is interesting. Look at C. It is, you take this part by itself. The 6th root of 729 is a positive and negative 3, but because they put a negative sign here, then they are clarifying we want the negative root of it. Okay? Now here, you know, I'm thinking this should be a positive and a negative. We've got the 4th root of something in here, so we want the positive and the negative of the 9. Okay? So you are always just being careful and watching whenever you have an even root squared to the 4th, to the 6th. Okay, so now let's go to the next part, which is the second page. Okay, so let's talk about how to do these, because you are now going to start bridging into the, for example 3s, not the example 4. We're going to start bridging into the part where you cannot do it in the calculator. But I tell you what, since 4 comes with a calculator anyway. Let's do 4, and then I'm going to spend a little more time on example 3. So here we go, example 4. So this is a word problem. It's not too difficult. This actually is something that commonly happens in some of our classes here. I know I do this a lot for my AP statistics. So here we go. Example 4 talks about that some teachers have to adjust the scores when a test is very difficult. One teacher's formula for adjusting the score is, and so this A stands for the adjusted score, is 10 times the square root of the grade that was received. So A is the adjusted score and R is the raw score. If the raw score on one test ranges from 36 to 90. Okay, so you see here we're going to be going from 36 to 90. And so we're just going to put those two in the formula. I'll turn this back on and then I'll have to erase. So we'll just put those back on the formula. And I'm going to put the low score here and the high score here. Then I just computed that in the calculator. I just went straight to the calculator and did 10 times the square root of 36. The square root of 36, of course, is 6. Okay, so then that's how I can get that on there. So 10 times the square root, 36. Of course, that one you could have been able to do in your head. And then here, the next one, 10 times the square root of 90. Okay, and so then that's how we're going to get 95. So therefore, the adjusted scores range from 60 to 95. Okay, now let's spend some time on example 3. This actually is going to kind of lead into what you're going to be doing tomorrow as well. So this will kind of get you a jump start on what you will be taught tomorrow. So what you're going to start seeing is problems that have smaller numbers that are more handleable, but they also have variables. So you need to know how to group what is under the radical. So you want to group this radicand according to the type of root that this problem is. So for example, I'm going to come over here and I'm going to take 16 and I'm going to break it down as far as it will go. So the first thing I think of is 4 times 4, and then these are 2 times 2 and 2 times 2. So in essence, the smallest that this 16 goes is 2 times 2 times 2 times 2. All right. Because it is a square root, I want to do groups of 2 items. So I've got this group of 2, and I've got this group of 2. So I actually have, when you have a group of 2, that item can now come out of the radical. So for example, this looks like this, 2 times 2 times 2 times 2. Okay, and we're just going to do the numerical part first. So when you have a group of 2, it can now come out of the radical as a whole 2, as a whole number, whatever this is. So a 2 can come out on the outside, and then there are 2 of these, so then another 2 can come out on the outside, and those multiply. That is how you are getting 4, because the square root of 16 is 4. And I know that you could have come up with that on your own. You probably would have known that the square root of 16 is 4. But I'm kind of pre-teaching you this technique that the other teacher will be showing you tomorrow as well. All right, so then let's take a look at our x to the 8th, okay? So, you know, the long way is that I've got 8 x's that are multiplying together. 1, 2, 3, 4, 5, 6, 7, 8. So think about putting these in groups of 2. How many groups of x squareds do you have? Okay, so I've got, this will come out as an x. This will come out as an x. This comes out as an x. And this comes out of the radical as an x. That then makes our final answer 4, because that came from the square root of 16. And then x to the 4th. because there were 4 sets of x squareds. Okay? So I'll explain that again here in part B. Alright, so let's take a look at this again with part B. Alright, so with part B, I've got a cubic group. So I'm going to be looking for groups of 3. So if I think about writing this all out, I don't have any numbers in there, so that's nice. But let's look at your A's. I've got 3 A's, and then we got the B's. We got 1, 2, 3, 4, 5, 6. Okay, so here is what you were thinking. Because this is a cubic root, I want items that are in groups of 3. So I have this one group of A's. I have 3 A's. That comes out of the radical as a full A. So this is coming out as a full A. And now, oh, you know what? I didn't draw enough B's. Okay, sorry. There's 9 B's. Okay, sorry about that. So now let's look how many groups of B's you have. There's one group of 3 B's. That comes out as a whole B. Here is a second group of 3 B's. That comes out as a whole B. Here is the third group of 3 B's. That comes out as another whole B. So that makes the answer A times B cubed. All right, then we'll do this last one. And again, this is going to kind of take you into exactly the way that you're going to be doing this tomorrow, okay? So this is a precursor to what you're going to be taught tomorrow. This will get you started there since you're going to be getting used to your new teacher. Okay, so what we have is the fourth root of, I got 8 x's. Okay, so this is getting a little ridiculous because we've got quite a few large numbers, and then I got 12 y's. 6, 7, 8, 9, 10, 11, 12. But me doing this concretely for you today is going to help you then eventually bridge to a shortcut. But let's do this without the shortcut for now. So I need groups of 4. In order for me to pull out an x, it has to be a group of 4 x's. So I have got this group that comes out as an x. These 4 x's come out as an x. These 4 y's come out as a y. These 4 y's come out as a y. And these 4 y's come out as a y. So I have got 2 groups of 4 x's. That comes from the 8 x's. And then I have got 3 groups of the 4 y's. Okay? So you can kind of either write that out if you need to see it concretely, or you can start seeing the shortcut there. You can just say, okay, x to the 8, that's going to give me 2 groups of 4. Okay, y to the 12, that's going to give me 3 groups of 4. And then you can go straight to that. Okay, so your assignment is to do the Chapter 6, Lesson 1, and then hopefully Miss Fanning you will finish this in class, and Miss Fanning then can stamp you and record your completion grade before the end of the class period.